I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take up some challenge examination questions. These have been selected by my IB student. We are going to solve these questions in a very simple way, connecting with what all we have learned so far in this unit. I hope you find it interesting and useful. Our approach, engaging minds, help us to perform much better. We can now connect to context, visualize strategy, apply learnings, and bridge the gaps. Engaging minds help in creative thinking and problem solving. Gain the confidence. Get ready for future. We develop both mathematical and social skills. I can be part of your success story. Build strong foundation and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Let us now enjoy the class with Arya. Hi Arya, how are you doing?
I'm good. How are you, Anil, sir?
Very good, very good. So today, what do you want to do?
It's again a mix of things.
Hmm?
So I have a question for rational functions, one for composite, and then one for the discriminant. So there's
Well,
three.
that's great. That's a good distribution. So you have involved the quadratic, rational functions, and polynomials, and what?
Yeah, just a mix of a lot of
Mix of
things.
all of them. That's nice. So when is your test?
It's in 2 days, so on Thursday.
Thursday. Fine. So which all things do you need to cover for the test?
There's a list of things I've sent to you, but there's the domain and range, composite functions, inverse functions of all the parent functions, logarithms, and like ln, but like when you're taking the inverse and stuff like that. There's also quadratics, like the discriminant, graphing, rational functions, but only if their numerator is like 1 over
Okay.
that, because that's
Yes.
the only format we've done so far, and transformations.
Great. So while answering your questions, I'll keep all this in my mind and I'll touch upon all these things which you are talking about so
Okay.
that you really get connected with the whole thing, even if we have a question which is in a different domain. Okay.
Okay.
So why don't you share what you have and then let's begin from there. Yeah, you can share
Yeah.
the screen now.
This is the first question.
Great. Can you please read the question?
So for the functions f and g, we know that f of x equals x squared plus x minus 2, and f of g of x equals x squared plus 7x plus 10 for all real numbers x. Find possible expressions for g of x in the form of g of x, x plus a, where you need to replace a with an integer number.
Great. So you're given the function f of x, which is equal to x squared plus x minus 2. Can you see my writing on the screen?
Yes.
I'll rather use some other color. Okay, so let me use this color. So you're given the function f of x, which is equal to x squared plus x minus 2. And you want to find the function g of x in the form x plus a, where a is an integer. So a belongs to integers. And you're also given that function f of g of x is equal to x squared plus 7x plus 10. That is what is given to you, right? So that is what it is. So what we can do is we really do not know the value of a, but we can figure it out by finding f of g, right?
Yeah.
So let us substitute. So f of g means f of g of x we have assumed to be at as x plus a, correct? Substituting x plus a, you get what? You get x plus a. Uh,
x plus a squared
Yes, x plus a whole square
plus
plus x plus a minus 2, right? So we can expand this. So you have x squared plus
2ax
2ax plus a squared plus x plus a minus 2, which
yeah,
simplifies to what? We have x squared plus the x term now is 2a plus 1. Do you see that? So 2a plus 1 is the x term, and the constant is a
How
squared
it's
minus 2.
oh, is it because you factored out an x?
Yeah, so always look for the x terms, right?
Yeah,
So factor out x from here. So you get the x terms and you get the constant terms, right?
yeah.
Now you compare the two equations. So from the two equations, you can say that 2a plus 1 is basically equal to 7, right? And a
I think
squared minus 2 equals to 10, right?
I think we forgot one a.
Where?
So you see x squared plus 2ax plus a squared plus x plus a minus 2? We factored
Oh,
out
yeah,
the
yeah, plus a, plus a.
x.
Yeah,
We
yeah.
didn't need the a.
You're right. So plus a, I should have. A,
Yes.
yeah. The order should be a squared plus a minus 2. Good job. So, yeah, I missed that. When you have a small screen to work with, right? Split here
Yeah.
and there, these things happen. So you have to be
No
more.
worries.
Well, from these equations, we can find the value of a. The first equation tells you that 2a equals to 7 minus 1, which is 6. And so a equals to 6 divided by 2, which is 3, right?
How did you
And
get that?
we just isolated a from 2a plus 1 equals to 7.
Okay.
You see this part. 2a plus 1 is the coefficient of x. So
Yeah.
that should be equal to 7, right?
Okay.
So
Yeah.
I just isolated a and got one
Oh,
value.
so you just found like the value of a for that one because a has to be 3 if it has to equal
It has to
7
be
over
7,
here.
right? The other one is a quadratic equation, which is a squared plus a, and bringing 10 to this side makes it minus 12 equals to 0, right? So I could factor this and write this as a plus 4, right? Times a minus 3 equals to 0, correct? So that gives me two values of a. One is minus 4, the other one is a equals to 3. So
Okay.
from both the sides, the common result is what? A equals to 3, right?
Yeah.
So therefore, a should be equal to 3. Is that clear to you?
Okay.
Does it make
Because
sense?
because x squared stays the same because that's what is in our composite over here, and then 2a plus 1 resembles our b value in standard form, so that's why we made that equal to 7 because that's what's given to us.
Yes.
And then we did the same thing here, except we just use our constant values and then made that equal to 10 because that's what is given to us.
Perfect.
Okay. Yeah, that
Does it
makes
make sense?
a lot. Yeah, it makes a lot more sense.
Beautiful. So that is how this brilliant question can be answered. Thanks for
Uh,
sharing it. Now let's move on and take another challenge question from your side.
sure. Let me just finish writing.
Sure. Yeah. So you have to take the common factor, right? Only one answer. A equals to 3 will satisfy both the parts, correct? Therefore,
Yes.
A equals to 3 is the only answer for that.
So in the format that we have to write it, g of x equals x plus 3. Is that
All
the
right.
answer?
Perfect. So
Um, this is the
that's
next.
what I wrote at the end, right?
Yes.
Gx equals to x plus 3. Perfect. Okay, so now you can share the next question.
This is the next question.
Okay, can you please read this question?
It's the discriminant question. So, for what values of p does f of x equal x squared plus p minus 2x plus 3p plus 1 have two equal real roots?
So 2 equal real roots means b square minus 4ac should be equal to 0, right? That's discriminant function which you're saying. You're given the function f of x as equal to x square plus p minus 2x plus 3p plus 1, right? So that is a constant term, right? So in this term, a is 1, b is p minus 2, and c is,
C is 3p plus 1.
correct, c is 3p plus 1. So now you can do b square minus 4ac, which is p minus 2
Yeah.
whole square minus 4 times a is 1 and c is 3p plus 1.
Yeah.
That should be equal to 0. So expand and simplify. So we
So
have
p
p
squared
squared, yeah,
minus 4p plus 4
yeah,
minus 12p minus 4. So p squared minus 16p plus 0 equals 0 because it has to be two equal real roots.
yeah. So now the value of p could be, I'll factor out p, right? And then we have
Equals p minus 16, which equals 0. So p can equal 0 or 16.
equals to 0. So p is equal to 0 or p is equal to 16, right? So we
Yeah.
get two answers for this particular question. Therefore, the option 4 is correct option.
Yeah.
Does it make sense to you?
That makes sense, yes.
Perfect.
And then this is the last question that I have out of all my questioning.
Okay, great. So can you please read this question?
Okay, so a rational function is defined by f of x equals a plus b over x minus c, for x cannot be c, and where a, b, and c is the element of the integers. The
Right.
following diagram represents the graph y equals f of x.
Right.
So they've given us a point P, which is on
On
the
the
x-axis,
correct.
and it's 6, 0. And using the information on the graph, state the value of A and the value of C. Find the value of B.
Perfect. So a plus b over x minus c. Now, what we have really done is we have a reciprocal function which we have shifted, right? Translated 4 units to the right, basically. So if you look into the transformation, c is the transformation, right? So straight away, we can write c as equal to 4, correct? Since
Yeah.
1
Because
over
it,
x
is it
will
because
have
it's
a
our vertical asymptote,
particular
right?
asymptotes, right?
Okay.
So that being the vertical asymptote, x equals to 4. So based on that, we know C value is 4, correct? Now the other important thing here is the horizontal asymptote. The horizontal asymptote is y equals to minus 4. Do you see that?
Yes.
So when x approaches a large number, so look here, when x approaches a large number, let's say infinitely large, in that case, b over x minus c, I mean, will approach 0, right?
Okay.
So f of x approaches a. Do you understand? So the value of horizontal asymptote is a. So therefore, we know a is equal to minus 4. Does it make sense to you?
So in our reciprocal function, whenever we have this value over here being A,
Yeah.
is that always our horizontal asymptote? Because
Yes.
it's a constant?
Yes. It
Okay.
is.
And the one in the denominator is always our vertical one.
Perfect. Now you're given the x-intercept, which is 6, 0. That means if I put x as equal to 0, then the y, I mean, if I put x as 6, y is 0, right? And we
Yeah.
already know what a and b is, a and c is. So let's write those values. We have now f of x as equal to what? A is minus 4
4
plus
plus
b is what for you?
B we haven't found yet.
B we need to find, and
Yeah.
we have x minus 4, correct?
Yes. X
Now we
minus.
have this. We'll use the point P, which is given to us as 6, 0. Substitute for x and y, right? So you get 0 equals to minus 4 plus b over 6 minus 4. Is it okay?
Yes.
So that gives you the value of b. Take 4 to the other side. So 4 is equal to b over 2, right?
Yeah.
So b is equal to 8. Is it okay?
H. Yeah.
So we get all the three values. We have a equals to, let me write down here. What is a? The
A
horizontal asymptote minus
horizontal.
4. Okay. And B, we worked out at the end as 8, and C is the vertical asymptote at 4. Correct?
Correct.
So that is how you're going to solve this particular question. Is that clear to you?
Yes.
Perfect. So, so with that, we can conclude what you wanted to know. Is there any other question?
I can check
Yes.
for if there are any that pertain to what I'm doing in class.
Sure.
Um, let's see. Oh, yeah, we can do this one.
Sure. So can you please read the question?
Let f of x equals to 2 over x minus a plus b, for x cannot be a. The line x equals 1 is
Vertical asymptote.
a vertical asymptote of the graph of y equals 4, y equals f of x.
Correct.
Write down the value of a. The graph of y equals f of x passes through the point p 0, 3. Find the value of b. Find the limit x is
Approaches
to
infinitely large
equal
value.
to infinity.
Hmm.
I've never seen this notation.
Yeah. I'll explain you this. Okay, don't worry.
Okay,
So it is very similar to our last question, correct? So
correct.
it says the line x equals to 1 is a vertical asymptote. That means the denominator will be 0 for x equals to 1, right?
Yeah.
So x minus a should become 0 for x equals to 1. That is what it means, right? Vertical asymptote.
So would that mean a equals 1?
Yeah, so 1 minus a equals to 0, and so a equals to 1. And so we get our value of a, first part. Now we need to graph y equals to f of x, which passes through a point P, 0, 3. Now if point P, 0, 3 is on the graph, we can substitute and find b, correct?
Correct.
So let's substitute. Now point P is 0, 3. So 0, 3 means x is 0 and y is 3. So 2 over 1 a 1 minus x minus a, sorry, plus b, right?
Equals 5.
So x is equal to 0, basically. So we have 3 equals to minus 2 plus b, and therefore b equals to 5, right?
Yes.
So since b is 5, we do have our function f of x. Let me write down here as equal to 2 over x minus 1, and b is 5 plus 5. So 5 will become your horizontal asymptote. Is that okay?
So if they were to give us a graph and then our horizontal asymptote was like already shown, then we would be able to see that 5 would have already been b, right?
Yes.
Okay.
So in this particular case, when you sketch the graph, it looks something like this. You have a vertical asymptote at x equals to 1 and horizontal asymptote at x equals to 5. And it passes through a point which is 0, 3, right? Since this is 5, it is passing through 0, 3. That means the function is on this side.
I see.
Oh, sorry, that 0, I went slightly. Sorry. 3 will be here, right?
Yes.
It is an asymptote, so the lines will not touch, right? So this is the vertical asymptote, x equals to 1. This is horizontal asymptote, which is b, which is 5, y equals to 5. Is it okay? And that is your y-intercept 3. So that is your graph, and it goes through the point y-intercept 0, 3 as shown here. Now let us try to understand this concept. Limit x approaches infinitely large value, find the value of f of x. So it really means what? It is called end behavior. You will learn more about it in calculus, but for now, it is end behavior. What happens to the function when x approaches a large value? It could be positive or negative. In this case, we are interested in figuring out what happens when you are approaching the large value, which is infinitely positively large, positive infinity. So in that case, what happens? If you look into this equation, which is f of x equals to 2 over x minus 1 plus 5, if x is very large, then denominator will be large, right? So we're talking
Yeah.
about something as 2 over infinitely large, right? Plus 5, correct?
Yes.
So that means 0 plus 5, right? So it approaches. We are never there. You cannot reach infinity. It is not a real number, but you can approach. So it approaches 5. That is what is the meaning of horizontal asymptote, right? So
Oh,
find this value is equal to 5.
5. So basically, when they talk about our limit and like approaching like a large infinity number, then we just look at our horizontal asymptote for that value?
That is the definition of horizontal asymptote. So how is horizontal asymptote defined? Definition of horizontal asymptote is if x approaches a large negative infinity and y approaches a value L, some value, real number,
Mhm.
then horizontal asymptote is y equals to L. Is it okay?
Yeah.
Also, we could write if x approaches negative and positive infinity, either side, and let us say y approaches a value k, then horizontal asymptote is y equals to k. You understand? We are approaching this value, but we are never there. So both
Yeah.
are horizontal asymptotes.
Let's
Most of
say,
the yes,
sorry. Let's say if our limit was like y is approaching infinity.
y
Then
is
what?
approaching when x approaches a value. So that is vertical asymptote, right?
Oh,
So
so okay.
so when x approaches a, right,
Yeah.
either from the right side or left side. See, then y approaches infinitely large value. You understand? In this
Yeah.
case, when you approach from the right hand side, y approaches positive infinity. However, when x approaches a from the left side, so we write minus on the top, y approaches negative infinity. That is from left. Do you understand? So if you
Yeah.
see from left of the curve, you are approaching negative infinity. And from the right of the curve, where a is equals to 1, you are approaching positive infinity. So these
Okay.
are the definitions of horizontal and vertical asymptotes. Is it okay?
Yeah.
Correct. So that is how we should be looking at it, right? Now, since you're talking about this particular reciprocal function, I will show you this function in a different light altogether, where we will take it as in the form of ax plus b over cx plus d. Okay.
Okay.
So if you have no other questions, I can explain you that concept now.
I had one
Okay,
question.
let's go through that question,
Um,
then we'll do. Yes.
it was more about like reciprocal functions when they have like the denominator being like a quadratic.
Okay,
How are you supposed to like graph them and how do you find the domain and range of it?
I will
So
just.
if you have an example, we
Oh
can
yeah,
look.
don't worry. I can create examples like nobody's business. Don't
Okay.
so you can start sharing, and
Okay.
I'll just take up a whiteboard and we'll go from there. Is that okay? But till now, have you understood all these concepts, right?
Yes.
Perfect. Good job. So now let's see. So we are now talking about reciprocal functions. So you want to know what happens when we have something like 1 over a quadratic function, right?
Yeah.
To keep things simple, let me write that quadratic function as in factored form. Let's say x plus 3 times x minus 5. Is it okay?
Yes.
Now, we're talking about reciprocal function. We'll also see sketch of this particular diagram. So what we are going to do here is first, we'll plot the denominator function, right? So basically, we are saying it is 1 over g of x. Is it okay?
Yes.
So I will first sketch the function g of x in green color. So g of x is a quadratic function which is equals to x plus 3 times x minus 5. Clear?
Hmm.
X it is a parabola which opens up with x intercepts at minus 3 and plus 5, right?
Yeah.
So I could actually sketch this function kind of like this. My drawings are rough, but they accurately show the results, right? Minus 3 and plus 5. So those are your x-intercepts, and definitely we have x is right in the middle of it, right? So this value of the x's is x equals to what? Add them, divide by 2, right?
Yeah. So 5 minus 3 divided by 2 is 1.
Perfect. So x equals to 1. So what is the vertex? Can you figure out?
The vertex is just you plug in 1 for these numbers. So it's
Right.
4 times negative 4, so 16.
Negative 16, right?
Yeah.
So negative 16 is your vertex. Now, to be very clear, you only need these 3 points to sketch your reciprocal function. Correct?
Okay.
Yes. So let's try to understand this part. At the x-intercept, g of x is 0. 1 over 0 is infinitely large. And therefore, we should have a vertical asymptote here, right?
Yes. Oh, so our x-intercept is our asymptotes?
Vertical asymptotes.
Okay.
So these are the vertical asymptotes. We'll call this is x equals to minus 3. And the other one is x equals to 5. Is okay?
Yes.
Two vertical asymptotes. Now, reciprocal of positive is always positive, and reciprocal of negative is always negative, right?
Yes.
That means these asymptotes have divided our plane into 3 parts, correct? Part 1, part 2, and part 3. 3 different parts, right? So this left side and right side will be positive, and the center portion will be negative because parabola is having negative values below x-axis, correct? Now, this portion on the two extremes, left side and right side, which are positive, they will have invariant points. You understand what are invariant points?
Yeah, I know what they are. I just forget how to like find them.
Invariant point is where y is 1. Because reciprocal of 1 is 1, right?
Yeah.
So if I just sketch a line, which is like, let me just, this is not an asymptote. It is just
Okay.
saying that y is equals to 1, right?
Yes.
And let us say it crosses the curve at these 2 points. Somewhere f of x will be 1, right? Is that clear?
Okay, so like whenever we plot these points down and we put our vertical asymptotes, if we were to sketch a line at y equals 1 along the like perpendicular to the parallel to the x-axis,
Yes.
then the points that intercept that parabola is going to be our invariant points.
You're right. And it is like a reciprocal function. So the graph of this will look like what? The graph will be,
There will be a rational function going that way and then another function going the other way.
you're right,
And then I believe the parabola will like flip.
inverted. Correct. Now, it is important to find the local maximum in this portion. So
Okay.
minus 16 is the minimum value of parabola, right? So when you do 1 over minus 16, you'll get something like this, which is 1 over minus 16. Is it okay?
So whenever we want to find our local maximum or minimum, we just go 1 over our y.
Yes, the
Okay.
vertex.
1 over the whole vertex?
Yeah, vertex y value. Maximum value becomes the minimum. I mean, minimum value becomes the local maximum in this case, right?
Yes.
And then we also have somewhere minus 1, right? So y equals to minus 1 is also invariant. So those are this point which you can see, right? So I'm just
Yeah.
marking them. Y equals to minus 1 in orange. And we have 3 critical points to sketch the graph. You see that?
Oh, okay. So for the parabola, our invariant points are when the parabola intercepts y equals -1. But for our rational functions over here, it's y equals 1.
So
And
both are plus or minus 1. Both, it is just a parabola. So the parabola is intersecting the lines y equals to minus 1 and 1. So wherever you have those two points where for plus 1, 2 points for minus 1 in this case, we'll have invariant. So 4 invariant points we got, right?
yeah.
So using that and the local maximum, which is reciprocal of minimum,
Yeah. So it's
You have to
1
be
over negative 1 over 16, right?
minus 1 over 16. So there you have your graph. Is it clear to you?
Yes, I understand that now because we have questions for like our test to do it like this, and I had no like I didn't understand like how to graph it, but now I get it.
Good job. Can you tell me domain and range of this f of x?
So the domain is x can be an element of the real numbers such that x cannot be -3 and x can't be 5.
You're right. And range?
The range, I think it's just I don't think there's a horizontal asymptote, so it's just the real numbers.
It is not touching the x-axis, and the local maximum is at minus 1 over 16. You see that? So
Okay, yeah.
therefore, so y value is less than equal to minus 1 over 16. You see that?
Why less than?
Because it is below this part, it is not above this, right?
Oh, okay. So if it's below the x-axis, it has to be less than or equal to?
Yes, yes.
Okay.
And means union, you can say, right?
Yes.
Union. Y is greater than 0. You see that?
Oh,
So
because
y is
these
not there
points are
in
greater
between
than
these two
0.
values. Greater than 0, because that's a
Mhm.
horizontal asymptote. Very important question. So is this concept clear to you?
Yes.
Good job. Now, let me give you a challenge question on this particular topic. Okay, are you ready for that?
I'm ready.
So we have a question here. F of x is equal to. So I'll give you a hint before giving you the question. Is it okay? Uh, my question is something like this. You have to sketch this particular function.
Okay.
Yeah, and tell me. First part is find the domain and range of the f of x, right? Uh, yeah. Okay, you can find it at the end also. Let us say this is 1 over g of x,
Okay.
where g of x is equal to square root of 25 minus x squared, right? So let's begin with domain and range of g of x.
So the domain is x is the element of real numbers such that it cannot be 5.
It cannot be 5 because it's in the denominator, or like in what sense?
Oh, it can be 5 because it's still square rooted. It just has
Yeah,
to be
it can be because g of x I'm taking as independent for now, right? So g of x square root of this, right?
yeah.
So g of x can be 5,
It
but
just
then
has to be less than or equal to 5 because it can't be
correct. Beautiful, correct, absolutely correct. So you can say absolute value of x is less than equal to 5. Is that clear to you?
yes.
Absolute value. See, 5 is included plus and minus. You get the idea?
Yes.
How about the range?
Um I think it's just y is an element of the real numbers, but if we graph it out, we can probably find the points.
We can probably find the points.
Yeah.
You are right. But okay, let me just show you this function. This is very important function. Uh, it has to be between 0 and 5.
Okay.
Let's try to understand this function. So I'm writing g of x once again in the form y equals to square root of 25 minus x squared. Okay. So
Okay.
we figure out that the value of x is within plus and minus. So we know this case y is greater than equal to 0 since it is a square root function. Is that clear to you? If I square both sides, I get y squared equals to 25 minus x squared, or x squared plus y squared is 25, where y is greater than equal to 0. Can you
Okay.
tell me what is this function?
I think it's the square root function.
X squared plus y squared equals 25, where y is greater than 0.
Okay.
X squared plus y squared equals to 25 is a circle, right?
Oh, it is?
Yeah. And if I'm only looking into y greater than 0, it is a semicircle.
I see. Because if it was a circle, it's not a function because it
It is
has
not a function.
the
But y
shape.
is greater than 0, therefore it is a function. It is a semicircle. You get the idea?
Yeah.
So it is a
I
semicircle with the x-intercepts at plus and minus 1, and also the y-intercept at 5. Plus and minus 5. And you get the idea now?
I understand. My only question is, if we had a function, how do we just visually like without like graphing or anything, how do we find like the range in the domain? Just by like
Okay.
pulling.
Square root functions, is always positive. Is it okay?
Okay.
Since there is a restriction, if you look into the square root function, general, right? So general square root function will be like this, correct? However,
Correct.
we have the term minus x squared. So that indicates that it is an even function and with some restrictions. You get the idea?
Yes.
Because so knowing slightly more than the function helps us to understand that it goes to two extremes as far as domain is concerned. And of course, when x is 0, we have the maximum value of 25. As x value increases, you are taking away something from 25, so it decreases, correct?
Yes.
So the maximum value is when x is 0, which is in this case 5. So you know
Okay.
that the range is from 0 to 5. You can logically also approach. Does it make sense?
Yes.
But knowing equations of functions and relations, for example, equation of a circle, x squared plus y squared equals to r squared, is important to know, right? So some
Okay.
students have done it, some have not, and therefore, if you've not seen it, it becomes a challenging question for you, correct?
Mm.
So good, we came across this. But my real question is much tougher than this. So let me now go to this part is clear to you, right?
Yes.
Good job. I'm going to make it tougher for you. Okay, so
Okay.
have patience, have patience. So okay, so we have done one part, and that is so I'm helping you out in finding the solution of this. That is my function, which is g of x equals to square root of x squared minus 25, right?
Yes.
This point being minus 5, that point being 5, and this is 5. Symmetric, even function. Now you have to sketch the function f of x, which is 1 over g of x, reciprocal function. So reciprocal functions necessarily are not rational. Is it a rational function? No,
No.
it is not a rational function because denominator is not a polynomial, right?
Yeah.
So know this, important to understand that this is a reciprocal function. Which is not, underline, a rational function. Many times students get an idea that reciprocal function is a rational function. That is not correct. Any function could be in the denominator. Reciprocal function is 1 over g of x, where g of x is a function. It could be sine theta.
Yeah.
So it is not a rational function necessarily. Is it okay?
Yes.
Now, how do you sketch the reciprocal of this function which is drawn on the graph? Tell me.
So the reciprocal function of g of x is 1 over square root x squared minus 25. So
Oh, I
what
wrote
I
x, sorry, 25 minus x. Sorry. I wrote the other
oh,
one. 25 minus x squared.
okay.
Yeah, sorry for that. Yeah.
No worries. What I would do is I would first take test points. So
Okay.
I'd make a table of values, so x, y, and I'd say that if x is -1, 0, 1, and 2, that's what I would start with.
Okay.
And then I'd calculate from there. So if 25 minus 1, so that's 1/24th, which is a very small number.
Okay. So
Then,
let me tell you in short.
yeah,
Your first step is correct. You should look into some test points, correct?
Yes.
That brings me to a very critical thing to understand. What should be our test point? Is that okay?
Yes.
What should be our test point? That's the beauty, right? We do not need many points. Last example, you remember, I just took 3 or 4 points, right?
Yes.
The test point number 1 is your x-intercept. You see that point?
Okay.
At this point, you have to draw a vertical asymptote. No calculations required.
Yes.
So,
And
and you have to label this as x equals to -5, x equals to +5. Already you got 1 point. You
then
get
will
the
we
idea?
just take our invariant points?
Beautiful. So then you have to take your invariant point. So let me sketch this also at 1, right?
Yeah.
And there you go. You have this point which is common to reciprocal function and this function also.
So
Good
if we
job.
want to just calculate, if we visually can't see, because here we can't see it to scale, but if we were to just calculate it, we just put our value of like 1 equals to 1 over square root 25 minus x squared
Yeah,
and do that.
correct.
So that would just be root 25 minus x squared equals 1, and then you just square 1. So
Correct.
that's 25 minus x squared equals 1. Negative x squared equals to negative 24. X squared equals 24. X equals root of 24,
Yes.
which I'll have to take on my calculator.
Yes.
So that's approximately like 4.9.
Yes.
And then you do the same thing, except you just do -1 because that's our second invariant point.
Correct. Now wait. Now wait.
Yes.
Let us look into this aspect. You are in an examination hall.
Okay.
You do not have luxury of time. Sitting at home, preparing, you can do all this. I love it. Just keep doing it, right? But not in the examination hall. We have to be like on the spot. So there are two terms which we normally use in a test paper. One is, let's look into these two terms, okay? One is
Okay.
called sketch and one is called graph.
Okay.
So one sketch the function or graph the function. When you sketch is a rough graph.
You don't need
You
to
don't need.
define the points.
You have to only show 5. Sketch means 5 parameters to get 100% marks. Even graph, 5 parameters. Parameters include horizontal asymptotes, vertical asymptotes, invariant points, maximum point, minimum point, even positive or negative. You understand?
Okay.
So now I got the vertical asymptotes. 2 points I've already indicated. 2 vertical asymptotes. You get the idea?
Yes.
On the graph, I will just draw the line and say this is a point where y value is 1, right? It cannot be -1. And so that becomes invariant point. Now I'll take the maximum point whose reciprocal will be 1 over 5, positive. And therefore, I will connect these points and sketch my curve, which is like this. Do you see this curve going? And I'm done. That is my graph of f of x. Do you see that?
That's it.
That's it. So 1 over 5, I have to label this 1 over 5. And my invariant points where the y value is 1. I'm not even calculating x value. I don't have that luxury. Is that clear?
Okay. Got it.
That is how we have to solve it. Is it okay?
But if they say graph, then you actually have to solve
Then,
it and then do
then,
it.
then you find, and for any function, like when you see circle with 5, then good. You remember Pythagorean triples, 3, 4, 5. You see that?
Yeah.
So that is a very beautiful point to consider because you know that x value is 3 or 4 or 4 or 3. You get the idea.
Mhm.
You already know this 4 and 3, right? So knowing some points in advance is even better, right? If you want more accurate graph. Is that clear to you? So knowing these points is good. Of course, you'll have to check for 1 as you were trying to calculate.
Yeah. So the 5 parameters of any reciprocal function is just your vertical asymptote,
Yes,
horizontal asymptote,
correct.
your invariant points,
Yes,
and then your local max or min.
perfect. That is it.
And that's it. So that's
That's it.
4, not 5.
Positive or negative with symmetry, there are so many things. It comes up.
Okay.
No. We this time we have two vertical asymptotes. We do not have any horizontal asymptote. You get the idea?
Oh yes, I see.
So there are many parameters which come up, right?
Yes.
Maximum value, local minimum value, all these are good points, right?
Yeah.
To mark. And also saying that the graph is above x-axis, always positive. Very important point. You get the idea. So
So
you
the
should,
graph is always above the x-axis?
yeah, it is positive, right? In this case,
Yeah.
you see that pink graph which we have drawn? It is positive, right?
But in the
Because
case that if it's like below the x-axis, then we have to state the um
in that
parabola.
case, domain and range was very critical. Did you see that range was in between, not missing, right? Between minus
Yeah.
1 over 5 and 0, right?
See.
Right.
So in this case, our range for this is
Yes.
that
Range.
x
Tell me range. Yes.
y is an element of the real numbers such that y has to be greater than 0,
Equal
equal
to,
to 0,
no, 1 by 5.
1 by 5.
Because
Oh,
that maximum
it's
will
not
be
at
1.5.
0. Oh, I didn't see that.
Do not miss it. This is very
Oh,
critical parameter,
okay.
right? And what
So
is
it's
the
it's
domain?
called either y.
Yeah.
Oh, that's x is an element of the real numbers such that x is less. It changed.
It is not including 5. You understand? It is not
Oh,
equal to absolute value of x is less than 5. It is not equal to 5. Do you see that difference now? Because the vertical asymptotes are there, right?
yeah.
Very good question. Now comes the challenge question. Okay.
So our vertical asymptotes, like when we have them, that's when we write it in like a cycle type notation here for a domain.
Cycle type means set
Like
form.
like cycle, it's like a cycle form, like -5 has to be greater than x, which has to be greater
Okay,
than
okay. Yeah, okay. Double inequality type.
yeah.
Okay, yes, you could do that. Yes.
Or can we just write like -5 has to be like less x has to be greater than less than -5 and then x has to be greater than 5.
No,
Like
no. If it is in between, that's the way you have to write. Is it okay?
oh, because the both of the asymptotes are there and the graph is in the middle of those.
Yes. In between.
Okay.
Now, we'll end the class with this beautiful question,
Okay.
which is f of x now is equal to, I'm using the same function. Do you see that beauty?
Okay.
Sorry, yeah, right. X first, always go back to this and say 25 minus x squared and minus, let's say 1. How will you
That's
sketch reciprocal of this graph?
okay. So basically, oh, it's not a reciprocal already.
Yeah, 1 over square root of 25 minus x squared minus 1. You have to sketch this graph.
Okay, so then it's 1 over everything, right? Again.
This minus 1 here.
Oh, but that's just our horizontal asymptote, right? So you'd go -1 and you put your horizontal asymptote there. And then 1 over 25 minus x squared, you just do the same thing again where you find your invariant points,
Let's
sketch
look
the
into this. So minus 1 will pull our graph slightly below the axis. You get the
yeah,
idea? So our graph now will be like
like that.
this. Is that clear to you?
Yes.
Earlier, these points were here, right?
Yes.
Now minus 1 means translated 1 unit down. Earlier, we knew exactly where the x-intercept is. This time we don't know. We'll have to calculate as you were trying to calculate for y equals to -1 or +1, right? But anyway, so you do that calculation, right? So you have vertical asymptotes at the x-intercepts of the graph. Is it okay?
Yes.
Or you could do it in 2 steps. You could do it in 2 steps. Let me do it in 2 steps. So we could do like that. Let's do it in 2 steps.
Is
So-
this already the reciprocal, or do we have to take the reciprocal of this function?
No, this reciprocal portion is here.
Okay, good. I thought we had to do 1 over 1 over this.
No. That is too difficult. That is too difficult. So so basically this part, right? And then we have to do -1. You get the idea?
Yes.
So basically, what you have here is you have your function already, reciprocal function, just as we sketched last time, correct?
Mhm.
So we'll do it in 2 parts.
Because
You
our
will-
horizontal asymptote is at 1 this time. I thought it would be at -1 because.
No. We'll first sketch this portion,
Oh, okay. We're just sketching the parent.
reciprocal of that part, and then we'll move the whole thing 1 unit down. You get the idea?
Oh, okay.
So that is how you're going to do it. So first portion will be, let me just sketch it in some list, right? So as we were talking about, this will be here, that will be there, and this will be here. So we have a function here, right?
Yes.
Okay. So once you sketch this function, you know this point is 1 over 5, right?
Yes.
Then you move the whole graph 1 unit down. Simple as that.
Oh.
Then you move the whole graph 1 unit down, right? So this becomes 1 over 5, right?
Mhm.
I mean, sorry,
It
1
just-
over 5 minus 1. You can do that, right? So
Yeah.
1 minus
it's just
5 over 5.
4 over 5
Minus 4 over 5.
minus 4 over 5.
Minus 4 over 5. Do you see that?
Mhm.
So this point comes at minus 4 over 5. Those points now become your x-intercepts. So you see that?
Yes.
And then you sketch your graph. Is that clear to you?
Yes.
So that is how, if I change my equation to -1 on the right hand side, first sketch the reciprocal part and then move your things up and down, translate it. Is that clear to you? It
Yeah.
becomes much, much simpler.
My question is, if our constant over here is -1,
Yes.
is that showing that our horizontal asymptote is supposed to be -1, or is it supposed to be 1?
Okay. Since here we do not have any horizontal asymptote. Why? Because the domain is absolute value of x is less than equal to 5. X is not approaching infinitely large value. You get the idea?
Okay. Oh, wait,
So
because it
no
can be
horizontal
both.
asymptote.
Okay, because it can be both.
It is
As
within.
long as it's less than 5, we're okay.
Yeah. Horizontal asymptote will be there only if you are considering x approaching positive infinity or negative infinity. Is that clear to you?
How do we know when that is occurring?
Okay. Good question. So let me ask you a question here. Provide examples for following.
Okay.
For one, for rational functions, reciprocal functions. Reciprocal functions without horizontal asymptote. Can you give me example?
1 over x plus 1?
Without horizontal asymptote. Without horizontal asymptote.
Oh, I have no clue.
Just now we did.
Oh, that one. Then yeah, it's 1 over root 25 minus x squared minus 1.
Only this one will also work. Why we complicate? You get the idea? No horizontal asymptote. Because our domain is
the
restricted to
only-
plus minus 1.
Okay.
And no vertical asymptote. Can you give me? No vertical asymptote.
1 over 25x. Oh no, but if just because of that, yeah.
So because
Okay.
there is no x-intercept, we do not have any vertical asymptote. You get the idea?
Yeah.
So-
Oh yeah, because there's no way this can equal 0 in any way.
Yeah. No way it could be because this is this, right? So
Yeah.
the graph of this function will be kind of like this. You see that?
Hmm.
Very important graph. You get the idea.
I got the idea, yeah.
So that is how functions, reciprocal functions could be. I hope you learned today's Couple of things, right?
Yes.
So I'd like you to just summarize the learnings and then we'll end the class today.
So we learned like rational functions and basically how to like graph them with like invariant points. And there's like four main parameters. There's like vertical asymptote, horizontal asymptote, invariant points being y equals to -1 and 1. And
Yes.
then your local max or minimum, which is basically your x value stays the same, but you take 1 over your y value.
Perfect.
And then we learned that some functions, there's like some few functions that won't have like a horizontal asymptote or like a vertical asymptote.
Yes.
And the one that doesn't have a horizontal asymptote is the one that we went through throughout this video for whoever is watching. So it's 1 over root 25 minus x squared minus 1.
Very good.
Um, and then the one without a vertical asymptote, I believe, was just 1 over x squared plus 1. And that's just because
Denominator is never zero. Correct.
it's never 0. And then we also learned how to find g of x if you're given like f of x and f of g of x's values. And basically the way you do that is you just substitute your g of x, like the value format that they've given you. So like, for example, if it was like 2x plus 2, then you just go f of 2x plus 2 and then substitute for all the x values being like 2x plus 2 and then solve from there. And then you look at like the values given for like x squared plus 7x plus 10, and then you like calculate from there, trying to like make it into those values to see. And then whichever two values or three values that are common, that's your value for like the variable.
Correct. Correct.
And then we did the discriminant.
Yes.
And we found how to find domain and range. So you can use like inequalities to do that for the domain. And then the range is usually just like your vertical asymptotes. Oh, sorry, your horizontal asymptotes. And it's
Correct.
usually your vertex value. And your domain, its restrictions are usually like the vertical asymptote.
Vertical asymptote. Perfect. So that's beautifully summarized. That's great. I'll actually share with you previous test papers after this lesson. So go through them. That will prepare you better for your
Thank
own test on Thursday. Okay, Arya?
thank you.
All the best.